Okay, I'm just going to go through the answers to this practice midterm to hopefully help you see what are some of the things that are going to be important for you to study. So the first question here, it says, which distribution is a good assumption for this type of data? And I kind of just give you three options: normal, binomial, Poisson. I said other, but I don't mean other. And what it is it's just sort of particularly the type of assumption about the distribution leads to a particular kind of control chart, and it also lets you understand like what are those distributions. So the first one is normal because it's actually measuring some kind of continuous variable, so that's not categorical. It's the diameter, which is it's in millimeters of the particular ball bearing. So that's a normal distribution. The second, it's a proportion. So if I say there's some sort of proportion, which means that it's some percentage that are doing this or not doing this, in this case it's defective or not defective, that is a binomial distribution. Poisson distribution, I don't actually know the best explanation for Poisson distribution, but it is something you're counting, so it's going to be integers, but it's also not limited in the positive sense. It could be it could go to infinity. On the negative side, though, because you can't count anything that's less than 0, it's limited by 0. So it goes from 0 to positive infinity. And if you can see anything that's like you can count like that, that would be a Poisson distribution. So the next one, the number of non-conforming teeth in a gear. So this is the proportion. This is, you're saying 2 of the 15 teeth are non-conforming, the other are conforming. So that's binomial. The next one here is a distance. So this is something you're measuring, so it's going to be normal. And binomial, again, it's the number, track the number of boxes that are within this tolerance. So the number of boxes in a batch of 10, a proportion, number within 10, that are within this. Now it's a little bit tricky because this looks like a measurement, but what I'm saying is how many conform to this measurement. So it's binomial. Now we don't know for sure whether, especially on the normal, we don't know if it's normally distributed, but this is a good starting assumption. That's all I'm asking you here. So in the next problem then, what we're looking at is saying, well, now that we sort of are looking at these things, what would be an appropriate control chart? So the ones that are normal, or something that you're measuring, you almost always are going to use an average chart, X bar chart, and an R. And you also almost always use both together. X bar and R are together. In these cases, you're using both of them. In the proportion, you're going to be using P. That's the chart you're going to be using. And again in this, the number of non-conforming parts. This number of scratches, so this is the Poisson distribution. This is a C chart that you're using. And I don't know how else to tell you that. It's just, you're going to have to remember that. Okay, so this next problem, number 3, is I'm asking you, a length of a pin is critical to the assembly of an item. The following 10 samples, so I'm saying we took 10 samples of 5 pins, so we took these 5 pins, we took samples of them, and you can assume the process is controlled and asking you to create a control chart, phase 1. So what I did is I transferred this data into Excel because it's easiest for me to do that, and I calculated the average and the range for each of these 10 samples. So you can see the average is the average of these. The range is the difference between the highest and the lowest value. The highest value is 12.1 and the lowest is 11.8, so it's 0.3. And then I calculated the X bar here and the R bar. And those are going to be the center lines of these two charts. For the X bar chart, I used the equation A2 times R bar to get the mean, plus or minus A2 times R bar. And A2 can be looked up on page 720, and in this case for an N of 5, we look at that number. So that means the ranges are between, the upper control limit is 12.74 and the lower is 11.47. So you can see, actually I drew it on here where the average is here and the upper and lower are here. Now for our chart, we have D3 is 0 for N of 5, and D4 is 2.14. So for upper control, you just take the range times that. So you can see this is what I have here, 0, 1.2, and 2.3. That is all you do on this sample. You just create these bar charts. So in this case, the question then is, so sort of separate now from the control chart, we're saying the customer has these tolerance requirements, that it be between 11 and 13 millimeters. So given the above sample, if we're going to assume that that sample is actually a representation of the population, we want to know how many parts per million will fall outside of this range. So I drew this kind of picture here where I have this distribution. We're saying the distribution of pin lengths looks like this, where it's centered around 12.128. We actually calculate the standard deviation from the R bar by dividing it by D2. We could calculate the standard deviation just actually by calculating the standard deviation, but I didn't do it that way. I did it this way. So now I have an S of 0.4, the standard deviation of 0.4815. And my question is, what's the probability that it falls below 11 millimeters and above 13? So we want to know how many parts are not conforming. So this is all I did. This P is, in my mind, representing the probability that the X, or any particular value, will be below 11 plus above 13. And I'm going to convert that to a z-score by taking X minus X bar over S, the same thing here, get a z-score, and then calculate, well, what is the probability that z is less than that value, or z is greater than that value. And I get a value of 0.04557, and I just multiply that by 1,000,000 to get to 45,570 parts per million. The next problem I'm looking at is we're going to be creating, in a process to make marbles, there are defectives that cause the glass to break at a later date. So below are 10 samples of 8 marbles, so 10 samples, and we drew out 8 marbles, and we have the number defective in each one. So make the appropriate type of chart, which in this case is a proportion chart, because we want to know out of 8 marbles how many are defective. And so we're going to do a P chart, and so P is the proportion defective. So in this case, I take for all of this, calculate the proportion defective, and then in order to get the S value, I take the square root of P times 1 minus P over N, which is the equation for standard deviation in a binomial distribution. And then we're going to take the P value plus 3 standard deviations, and then plus minus 3 standard deviations. Now this is a minus number, so I'm just going to put it to 0. So you can see here I have 0 and 0.1375 and 5.32. Now in part B, I'm saying, okay, now we're going to take samples. In this case, we're taking 10 samples, and we have this many proportion defective. So what I'm going to do here is I calculate the proportion defective on these, and I'm plotting them, these 10 values, on the control chart. This is phase 2. And in this case, I would say the process does seem out of control. One point is at the 3 standard deviations, and they seem to have an upward trend. So that would be the reason that you would say this is possibly out of control. And then I'm asking you here to discuss the 8 dimensions of quality. I put these in forms of questions, but you could also put them in forms of statements about what would be a quality for a marble. Then the next, so I'm not going to read that, you can read it. The next question is, from these interviews, I'm asking you to create a Pareto chart. Now, what I've done here is I kind of highlighted things that seem common. Like in this first example, they talk about the fasteners, and at the last example, 2 people talked about fasteners. Talking about problems with the punch press, one of them blamed Sue and the other blamed the actual press. 2 of them blamed Sue and 1 blamed the press. But they're all saying that's the function that's off. And then another person said there was some sort of rushing going on. People were rushing. So what I did is I created a simple Pareto chart where I have 3 people said punch press, 2 and 1. And then from there I would say we need to really start looking at the punch press setup, that what's going on with that. So then I created a DMAIC, kind of an analyze, and I put the possible tools you would use, etc. It's pretty much out of the book. It's not very complex. The next one I did on number 6 here is I asked you to look at making cookies, and look at the process of making cookies and do some sort of a process. Well, I asked you to create a quality system out of this. So what I did is I created a process flow chart, and I marked at the places where we could be doing some sort of quality checks. And then for each of those quality checks, I went through and say, this is what we have to do. This is exactly how we have to do it. And there's the question of how to make these decisions. I arbitrarily did them, but we need to think about, well, how could we make that decision? And I think I talked about last time about the cost of implementing versus the cost of the defective, and having to contrast that somehow. And this last one, I just created my own little cause and effect diagram about burning the cookies, and I have the different categories, etc. Now I hope that that is going to be helpful for you as you try to study for the exam.